you. In this video, we will be considering an additional term, that is thermal stress. We all know that if we heat a metal rod, the rod will be elongating or expanding along its length. We call it as thermal expansion. Now, I consider a situation here. That situation is this. I have two clamps here, the fixed clamps. In between those two, I am holding a metal rod of length L and area of cross section A. So I am clamping it there and no additional stress and other thing is coming. But if I start heating this metal rod, if I start heating the metal rod through a temperature delta theta, due to that increasing temperature, you can find that the rod will be trying to elongate, but the clamps are not allowing it to expand. So on these two clamps there comes what? A force of pushing, and that develops what you call a stress on it. That stress is what we call thermal stress. Now, if I remove this clamping and all, the metal rod will be free to expand along. So when it expands along, there is a small expansion length is coming delta L. That will be equal to alpha into L into delta theta. That is, elongation, thermal expansion depends on the original length, and rise in temperature, and alpha is called coefficient of linear expansion. Coefficient of linear expansion of the material. Now, depending upon the material, you can find the value of this one from the data book. You can substitute and find it. Then, if this is the expansion that is coming here, then delta L by L will be equal to alpha into delta theta. From this equation, if you allow it to expand, then this is nothing but the fractional increasing length, or we call that as longitudinal strain. Fractional increasing length means increasing length to the original length, and actually that is named as strain in the previous case, that the initial video we found out. So delta L by L is nothing but the strain produced by heating here, and we call this as thermal strain. Thermal strain. So thermal strain is now equal to delta L by L, that is equal to alpha into delta theta. That is coefficient of linear expansion into rising temperature. Okay. But we know that Young's modulus is now equal to stress divided by strain. Therefore, stress will be equal to Young's modulus in the strain, but strain is thermal strain, therefore thermal stress. Thermal stress therefore will be equal to Young's modulus into thermal strain. Thermal strain, and therefore thermal stress is equal to Young's modulus into alpha into delta theta. So, this is how we are finding the thermal strain relating to the heating of the material. So, thermally produced strain called thermal strain. Thermally produced stress we call it as thermal stress. This linear expansion and all, don't worry, you will be studying in heat and thermodynamics chapter. It's a very simple thing. But the terms I discussed here is along with the stress and strain. That's all.